Trigonometric identities, the Pythagorean identities. So we have here three Pythagorean identities of trigonometric identities. We have the Pythagorean identity for sine and cosine, and then the Pythagorean identity for tangent and secant, and then lastly for the cotangent and cosecant. So we will know where these identities came from and how was it derived. So assume that we have a right angle triangle where we have side A, side B, and side C. Side A will be our opposite, side B is our adjacent, and side C is our hypotenuse. We already know about the SOHCAHTOA SOHCAHTOA, or the terms for us to remember the trigonometric ratios. So we are going to recap. So for SO, we have sine x is equal to opposite over hypotenuse. For K, we have cosine x adjacent over hypotenuse. For TOA, we have tangent x is equal to opposite over adjacent. For SHO, we have cosecant x is equal to hypotenuse over opposite. And for SHA is equal to secant x is equal to hypotenuse over adjacent. And for COW, we have cotangent x is equal to adjacent over opposite. So we can simplify these equations or ratios by integrating the sides A, B, and C to its names. So for A, we have opposite, B, we have the adjacent, and C for the hypotenuse. So for sine x, we can simplify it as A over C. For cosine x, B over C. For tangent x, A over B. For cosecant x, we have C over A. For secant x, we have C over B. And lastly, for cotangent x, we have B over A. So we will set aside all of these values for us to use later on. So we all know about the Pythagorean theorem, which states that a square plus b square is equal to c square, which is true for all right angle triangles when we are finding for the length of the sides. So this Pythagorean theorem or equation, we will use it for us to come up to this identity for this sine and cosine identity, which is sine square x plus cosine square x is equal to 1. But how? So first, as you can see, we have a value of 1 on the right side of this equation. And we have here c square. For c square to be equal to 1, we have to divide both sides by c square. So that is what we are going to do. So we are going to divide both sides by c square. So we will have this. So after that, c square over c square will become 1. And this term here, a square plus b square over c square, we can separate this as two terms. So a square over c square, we can furthermore rewrite it as a power, or a over c to the power of 2. And same as for the b square over c square, b over c to the power of 2. As you can see, we have AC here, and we have also AC here, which is equal to sine x. So we can replace AC or a over c as sine x. So it becomes sine x to the power of 2. And also BC. BC can be cosine x. So we will replace BC by cosine x. That becomes cosine x to the power of 2. So we can furthermore rewrite it or simplify it as sine square x plus cosine square x is equal to 1. So now we have a similar equation here. So this is our first identity, Pythagorean identity for sine, which is sine square x plus cosine square x is equal to 1. So we can also derive it furthermore when we transfer cosine square x to the other side. So we will have sine square x is equal to 1 minus cosine square x. And then also, if we transfer sine square x to the other side, we will have cosine square x is equal to 1 minus sine square x. So we will set this aside. So next is this 2. So we still have two identities. So we go back to the Pythagorean theorem. So since we are already done with the c square, we can either divide both sides by a square or divide both sides by b square. So for now, we will divide both sides by a square. So we divide both sides by a square. So we separate this. So we have a square over a square plus b square over a square. So we have a square over a square is equal to 1. And b square over a square, we can furthermore rewrite it as b over a to the power of 2. And c square over a square will become c over a to the power of 2. We already have the value for b over a. B over a is this, which is cotangent x. And for c over a, we have cosecant x. So we can furthermore rewrite it. So it will become 1 plus cotangent square x is equal to cosecant square x, which is equal to this equation. And then we can furthermore derive it where we transfer cotangent square x to the other side. So it becomes 1 is equal to cosecant square x minus cotangent square x. And also, when we transfer 1 to the other side, it becomes cotangent square x is equal to cosecant square x minus 1. So lastly, for this equation, we will go back to the Pythagorean theorem and we will divide both sides by b square. So divide both sides by b square, and this term will be separated, and then b square over b square will become 1. And then a square over b square will become a over b square. C square over b square will become c over b to the power of 2. So a over b will replace it as tangent x. And then c over b is secant x. So furthermore rewrite it as tangent square x plus 1 is equal to secant square x. So these are similar equations already. Even though the leading term here is, or the first term is 1, so they are still the same because the operations between them is addition. So let's proceed. 1 plus tangent square x is equal to secant square x. So we can furthermore derive it. So if we transfer tangent square x to the other side, it will become 1 is equal to secant square x minus tangent square x. And then if we transfer 1 to the other side, it will become tangent square x is equal to secant square x minus 1. So we are already done in proving the three identities or the Pythagorean identities of the trigonometric identities. But how do we know if these identities are true or legit? So does this satisfy all of the values for x? So let's try. So first, for the sine square x plus cosine square x is equal to 1. We assume any value for x. So for now, we will assume x as 45 degrees. So we can rewrite this sine square 45 degrees as sine 45 degree to the power of 2 and cosine 45 degree to the power of 2. So we will find what is the value for sine 45 degrees. So sine 45 degrees is 1 over square root of 2. And for cosine 45 degrees, we also have 1 over square root of 2. So 1 over square root of 2 to the power of 2, we distribute the square. So 1 square is 1. Square root of 2 square is 2. And then also the same for the other term. 1 square is 1. Square root of 2 square is 2. So we have here on the left side 1/2 plus 1/2 is equal to 2 half, and 2 half is equal to 1. So 1 is equal to 1. So it is true. So this identity is correct or true. So for the next identity, 1 plus cotangent square x is equal to cosecant square x. So we assume x as 30 degrees. So we can rewrite this, and then cotangent 30 degree is square root of 3. Cosecant 30 degree is 2. If you don't know the value for these identities, or shall we say this cotangent and cosecant, you can input it on a calculator in degrees. So let's proceed. Square root of 3 square is 3. 2 square is 4. 1 plus 3 is 4. 4 is equal to 4. It means that this equation is true. Next, lastly, is 1 plus tangent square x is equal to secant square x. So we assume that x is 60 degree. We rewrite this, and then tangent 60 degree is square root of 3. Secant 60 degree is 2. So square root of 3 square is 3. 2 square is 4. So 1 plus 3 is 4. And 4 is equal to 4. So it means that it is also true. So for these three identities, they are all true for any value of x.